हाय माय डियर फ्रेंड्स, कैसे हो सब। आई होप अच्छे हो सब एंड पढ़ाई भी अच्छा ही चल रहा होगा। सो कंटिन्यूइंग फ्रॉम द प्रीवियस क्लास, in the last we discussed about alternating series and one test that is called Leibniz test. Let's recap it by an example. Suppose my series is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, continuing like this. See here, my all in every series, not it is not the case that always an will be given. So in some series you have to find what will my an. So what will my an here? My an will be minus 1 to the power n plus 1 by n. Yes. So this is an alternating series. So for checking the convergentness or divergentness of this series, I have to check the Leibniz test. What is the Leibniz test? First condition, it should be monotonically decreasing. Consider this one. Yes. So it should be monotonically decreasing, means we know 1 by n is greater than equal to 1 by n plus 1 because n plus 1 is greater than equal to n. So it is monotonically decreasing. Second thing, limit n tends to infinity 1 by n is equal to 0. So it is satisfying both the conditions. That's why this series is convergent. Okay. So let's discuss now two small definition. Then, so one is absolutely convergent. One is absolutely convergent, and another definition is conditionally convergent. Conditionally convergent. Let's understand this. So from since the childhood we know what is absolute value. Suppose if I ask you what is the absolute value of -3, what you will do? You will keep mod, means that is equal to 3. Suppose absolute value of 4, it is also equal to 4, means absolutely convergent. Suppose my series is an. My series is an. When I will call this series absolutely convergent? If my mod an is convergent. If my mod n is convergent, then only I will call this absolute convergent. What is conditionally convergent? If an is convergent but mod an is divergent. Okay. If an is convergent but mod an is divergent, then I will call this as conditionally convergent. See here, we discussed just now the example series of minus 1 to the power n plus 1 by n, which comes as convergent. But if you take the mod, then what will come? The series will come as 1 by n, and we proved this is divergent. Also you can say by p series test, because 1 by n to the power p, here p equal to 1, and we know it is convergent if and only p is greater than 1. So this series is divergent. So overall I can say this series is conditionally convergent. Clear? So let's come to a theorem. What the theorem says? Every absolutely convergent series is convergent. Means if mod n is convergent, then n will also convergent. No need to check. Okay. If mod n is convergent, then my n will also be convergent. No need to check here. So let's consider some example. Let's my first example is, suppose summation of minus 1 to the power n plus 1, 10 to the power n by n plus 1 factorial. Here n from 1 to infinity. See here. So let's say this is my an. This complete is my an. So I have to examine this series will be conditionally convergent or absolutely convergent or divergent. Yes. So just take the mod. What will be mod of an? Means I am taking it as another series. Let's say bn. It is equal to 10 to the power n by n plus 1 factorial. So which test you will like to adapt here? So I will use ratio test, because factorial term is there. If you use power, if you use root test, means power 1 by n, it will be more difficult for you. So limit n tends to infinity bn plus 1 divided by bn. Do it. Limit n tends to infinity 10 to the power n plus 1 by n plus 2 factorial into n plus 1 factorial divided by 10 to the power n. See here, 10 to the power n, this will get cancelled out. This will n plus 2. If you put infinity in place of n, what you will get? 10 by infinity means 0, which is less than 1. That means this series is convergent. Bn is convergent. Means mod n is convergent. That means this series is absolutely convergent. This series is absolutely convergent. And also every absolutely convergent series is also convergent. Means this series is convergent also. So let's consider another example. Suppose my series is minus 1 to the power n plus 1, 1 by ln n. Okay, n from 1 to infinity. Let's say 2 to infinity. Okay, because ln 1 equal to 0, it will come as infinity. So see here. So let's say this is my an. This whole. I am taking the mod. Bn will be mod of an. It equal to 1 by ln n. So how can I check? You can either do by limit comparison test or you can do by comparison test. Okay. Also you can do by ratio test. Let I am using ratio test. Limit n tends to infinity bn plus 1 means 1 by ln n plus 1 ln n. If you put infinity, you will get infinity by infinity form. Limit n tends to infinity 1 by n, and the difference of this one will be n plus 1. Means what you will get? Again infinity by infinity form, again differentiate 1 by 1 equal to 1. So sorry, this test will fail. You can't apply this. So you have to again go to the comparison or limit comparison test. So let's say I am using limit comparison. Let's say Cn is 1 by n. So limit n tends to infinity Bn by Cn will be equal to limit n tends to infinity n by ln n. So we will get infinity by infinity form, then just differentiate limit n tends to infinity 1 by 1 by n. That means it is equal to infinity. If you are getting infinity and this is also divergent, this Cn is divergent, so my Bn will divergent. My Bn will diverge. That means it is not absolutely convergent. It is not absolutely convergent because my mod is not convergent, my mod is divergent. So let's check this one. Let's check this one. And this is a alternative series. So how can I check? I have to apply Leibniz test. How can I apply Leibniz test? First I am considering the limit. Limit n tends to infinity 1 by ln n it equal to 0. Means 1 by ln infinity. Ln infinity equal to infinity. Ln infinity equal to minus infinity. So 1 by infinity will be 0. So this condition satisfying. Let's take the first condition. And we know if n plus 1 is greater than n, greater than equal to n, then can I write ln n plus 1 is greater than equal to ln n? Means 1 by ln n plus 1 is less than equal to 1 by ln n. So this condition also satisfied. So this series is conditionally convergent. This series is conditionally convergent. Let's consider another example. Suppose my series is summation of minus 1 to the power n plus 1 2 to the power n by n square. Here n from 1 to infinity. Okay. So here this is my n. I am considering the modulus, the absolute value. Let's say that is bn, which is equal to mod n equal to 2 to the power n by n square. Here you can apply for testing the convergentness of this series. You can either apply ratio test or root test. I am applying, let's say, root test. N tends to bn power 1 by n, 2n by n square power 1 by n. It will become limit n tends to infinity 2 power n into 1 by n. This will become n power 2 into 1 by n. So I can write here limit n tends to infinity. This n and n will cancel. This will be n power 1 by n whole square, and this value equal to 1. If you don't know, go through just the lecture number 8, evaluation of limit. So this will come as 2, which is greater than 1. That means this series is divergent. This series is divergent. So this is not absolutely convergent. So this series is not absolutely convergent. Let's check about it, whether it will be conditionally convergent or not. So this is my mod. So I have to apply Leibniz test. I am checking just the limit. Limit n tends to infinity 2 to the power n by n square. If you put infinity, you are getting infinity by infinity form. Differentiate limit n tends to infinity 2 to the power n ln 2 divided by 2 to the power n. sorry 2n. Again you are getting infinity by infinite form. Differentiate, limit n tends to infinity, 2 to the power n ln 2 whole square divided by 2. If you put infinity, you are getting infinity. So it is not satisfying the second condition of the leveling test. So this series is also not convergent. So it is neither absolute convergent nor conditionally convergent. This series is divergent. This series is divergent. Hopefully what I explained you all understand it well. So here I am finishing this series of sequence and series. पढ़ाई करते रहिए. All the very best.